Hello, Algebras. We are continuing to talk about radical functions and their inverses. Whoops, that's not what I wanted to do. We are on page M324 if you want to follow along in your book. So first we have this graph g of x equals x squared minus 4. It's graphed for us, and they're asking a basic transformation from our parent function. So we know our parent function exists here, and we can see that it translated down 3 units. Next, they want us to write the equation for the inverse. So it seemed that there was a bit of a disconnect or a struggle on writing the inverse from yesterday's lesson, so hopefully this makes it a little bit more clear, or at least you're going to see another example of it. So remember, anytime you have that function notation, it's just a representation of y. So we have y equals x squared minus 4. So that is our function. Now to find the inverse, we're going to swap places with the y and the x. So what we have is we have x equals y squared minus 4. So notice the equation stayed the same. X and y just switch places, but everything else is the same. Anytime that you are dealing with graphing or functions or really any equation in math, if your equation is not solved for y, then you are not done with the problem. You always have to solve for y. That's just kind of a good general rule of thumb to remember. So we see our inverse is not solved for y, it's solved for x. So we need to get y by itself. My first step would be add 4. So we have x plus 4 equals y squared. Y is still not by itself. We need to take the square root of both sides, and we would get plus or minus the square root of x plus 4 equals y. Now, if you don't like to see it written this way, you can reverse it. And there we have it. So this would be the inverse of that. All right, so if we sketch this graph, so let's create a quick table real quick. Let's make sure that they come out to nice, pretty numbers. So if we have -4, -2, 0. Wait, no, -2 wouldn't make it pretty. 0, 5, and 12. Okay, so where I was coming up with those numbers, I was just seeing what we could add to 4 to make it a perfect square. Okay. So if we substitute -4 in for x, then we get 0, and the square root of 0 is 0. If we substitute 0 in, 0 plus 4 would be 4. The square root of 4 would be 2. If we substitute 5 in, 5 plus 4 would be 9. The square root of 9 is 3. And if we substitute 12 in, 12 plus 4 is 16, and the square root of 16 is 4. So again, I just picked x values that would make this easier to graph. All right, so now that we have our table made, we can graph this. So our x value is -4, 0. So -4, 0, 0, +2, 5, +3, and then 12, +4 would be off the graph. Now, one thing that we don't have shown on our table right now that we need to show on our graph is that this plus minus, so this plus minus right here, we have to take into account that those values can be negative outside of there. So we're going to take our y values and we are going to graph the opposite of them, because this shows us that it can be positive or negative. Okay, and the y value is not going to change other than it being positive or negative. So we have -4, 0. Now 0 is neither positive nor negative, so it'd be the exact same point. And then we had to have 0, -2, so 0, -2, 5, -3, and then 12, -4 would be off the graph. So that's kind of bad. There. All right, so there we go. Now, is the inverse function, or is the inverse a function? So the easiest way to graphically tell if something passes the vertical line, or is a function, is if it passes the vertical line test. And right away it fails. It hits twice, fails here, fails here, fails here, fails everywhere. So no, our inverse is not a function. So I'll leave that up there so you can remember. Whoa. That. So it failed here. It just has to fail at one point for it to not be a function. So. All right, and then the transformation, so the parent function of the inverse would be here. So it transformed, it went 4 units to the left. I'm not super picky about the transformation stuff, but we'll answer it because we're here. All right, list the domain and the range. So this is kind of something that sometimes we struggle with. So our regular function, which is graph. So the domain, remember we're looking at where it exists left and right. So this is going to continue to get wider and wider and wider forever and ever. So there's never going to be an x value that it doesn't come in contact with. So our domain would be all real numbers. That's the symbol for all real numbers. You can list it out if you want. All right, but our range, remember the range, we are looking at where it exists up and down, the y values. So it's going to continue to go up forever, and there's going to be no y value that it doesn't come in contact with above our minimum point. Okay, so our graph does not exist below -4. Therefore, our range would be y is greater than or equal to -4. Okay. So that would be in, as an inequality, in interval notation, it would be from -4 to infinity and beyond. Now looking at the inverse. So our inverse, we're looking at the x values. So as we move to the right, it's going to hit every x value along the way, and it's going to come in contact with every single x value except to the left of our furthest point. So this graph is not going to hit these x values back over here. So our domain only exists with the x values that are bigger than -4. Okay. So again, notice on the domain we're using x. So as an interval notation, it would be -4 to +∞. And our inverse again would be plus minus the square root of x plus 4. Now our range, again, we're looking vertically. So this is going to continue to get bigger and bigger forever, and this is going to continue to get bigger and bigger forever and ever. And there's going to be no y value that it doesn't come in contact with ever. So our range is going to be all real numbers. Remember, that's the symbol for all real numbers. In interval notation, it'd be -∞ to infinity. I guess we could write that over here too. I don't really care what notation you use. So what conclusions can we make about the relationship between the domain and range of the quadratic function and its inverse? When the this is the important part. I'm going to highlight it. When the domain is not restricted. So right now our domain is not restricted. We'll talk about it in the next video when we restrict that domain. But just kind of internalize it, look to see what we have here. Maybe you can make some conclusions, maybe you can't, maybe they have some things in common, some conjectures you can make. So go ahead and think about that, jot down your thoughts and opinions, and in our next video we're going to talk about restricting that domain and seeing what happens to the function. Happy mathing!